Hi everybody, welcome back to our videos. We have 3 more units to go. So this is Unit 10 and this is Lesson 1 from Unit 10. And this unit is on kinetics and equilibrium. And the first thing I'd like you to do in your notes under Section 1, you have 2 diagrams, A and B. And I want you to jot down in the space under the this little sentence is, what is the difference between collision A and what is the difference between collision B? So how are collision A and collision B different from each other? So take a minute and look at those and jot down a couple ideas. We'll talk about your responses to that question in class tomorrow, but just jot down a couple ideas. There is this thing in chemistry called the collision theory, and the collision theory states that atoms or molecules will react if 3 things are true. Number 1, if they collide. So they have to hit, they have to bump. If they do not hit each other, they do not come in contact, they will not react. So they have to hit, they have to collide with each other. That's why this is called the collision theory, because in order for things to react, they have to hit. Not only do they have to hit, though, because right now oxygen is hitting my head, but my hair is not on fire, okay? Because it's not enough to just hit. They have to hit with the proper energy. All chemical reactions require some startup energy. And obviously the oxygen in my hair don't have enough of that startup energy. I could provide them more energy, but they're not going to react until they have the sufficient energy. Okay? The analogy to this is, think of this hill, this ball in the hill. The reaction would not begin. RXN is the abbreviation for reaction. The reaction would not begin until the ball got to the top of the hill. So right now, my oxygen and hair have this much energy, but in order to react, they need this much energy. So you'd have to supply this much startup energy in order to make that reaction occur. That startup energy, or the energy needed, is called activation energy. The energy needed to activate the reaction. So they have to hit, and they have to hit with enough energy, and sometimes there's a steric factor or an orientation factor. They must collide the right way. They have to collide with the proper orientation. Okay? So they have to collide with the proper orientation. An example I can give you of that is this reaction. So draw this. Looks something like this. This is an H here. If the molecules hit this way, then you will get a reaction occurring where water is made, okay? And some other things, blah, 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 blah. But if you flip either one of these molecules, like let's flip the first one, so that the OH group is on this side, and just H is on this side, we'll flip the other one too, just for fun. So if this collides with the C, then you get no reaction. So for certain molecules, it depends on how they hit each other. It's not just enough to hit. They have to hit with the right side of the molecule hitting each other. They have to hit with a proper orientation. So they have to hit the right way. So the next little section on the first page of your notes asks you to look at these two things. The top one is labeled effective collision, and the bottom one is labeled ineffective collision. And based on what you see in the diagrams, write a statement at the bottom here that describes the difference between an effective collision and an ineffective collision. What is an effective collision? What is an ineffective collision? So take a note there, and we'll talk about that tomorrow too. So you might want to pause the video because I'm going to continue. Kinetics is really the study of how quickly reactions occur, how fast reactions occur, or the speed of reactions. Because some reactions we want to occur really fast, like if we're making a drug, if we're making penicillin, if we're making some kind of drug that we need to sell and we need large quantities of it, the flu vaccine, for example. We want that reaction to work very quickly so that we can get that product out to market and everybody can be vaccinated with the flu vaccine. So we would want to speed up reactions. And if we understand how they work, then we can do things that would make reactions go faster. Other reactions we want to slow down, like for example, the rotting of our food, right? I do not want to open my yogurt and have it be rotten. And so therefore, I slow down those reactions that cause decomposition or rotting to occur. And I slow them down by putting and storing my yogurt in the fridge. So some reactions we want to go fast, some reactions we want to go slow, and in this unit we'll be studying factors that affect how quickly reactions proceed, okay? So there are certain factors that affect the rate of a reaction. The first one is temperature. The higher the temperature, the faster a reaction will go. Okay? Therefore, we can say, as temperature increases, the rate of the reaction will increase. If you want a reaction to go faster, heat it up. If you want your yogurt to spoil quicker, heat it up. Okay? The faster the reaction is, the higher the temperature, the faster the reaction will go. There's two reasons. Okay? Number one is there'll be more collisions. If you add energy to the molecules, they move faster, and there's a greater chance that the molecules will hit each other. Okay, so there are more collisions at higher temperatures. And remember, having a collision was one of the things you needed to do in order to react. Okay? The second thing is, at the higher temperature, there will be more effective collisions. At a higher temperature, there is a greater chance that the molecules have the necessary activation energy to react. So not only are there more collisions, not only are they hitting more, they're hitting harder. And if they're hitting harder and they have more energy, chances are they're at the top of the hill. And they have the necessary activation energy in order to cause the reaction to happen. Okay, so there's more collisions at higher temperature, and there's more effective collisions. Temperature does not really affect that orientation or that steric factor. Concentration is another factor that affects the rate of a reaction. If you increase the concentration, their reaction will occur faster because there will be more collisions. Okay? There'll be more bumping because now there's more molecules to bump. So most reactions will occur at a faster rate if the concentration of a reactant is increased. And I'll show you a demonstration of this tomorrow in class. The opposite is also true. If you lower the concentration, you lower the rate of a reaction. And this will occur because if there's more reactants, meaning a higher concentration, there are more molecules present in the container, which will increase the number of collisions. Pretend you're all molecules. And if there's only 2 of you in the classroom, there's a very low chance that you will collide with each other if you move about randomly. But now if I put 100 students in the classroom, there's a greater chance of collisions. Okay, so the more concentrated, the more atoms or molecules there are, the greater chance of collision. If there's a greater chance of collision, there's a faster reaction rate. Okay? So I demonstrate that here. If the square needs to hit the circle, there's a greater chance they'll hit in the higher concentration of squares and circles compared to in the lower concentration. So this will have a faster reaction rate. This will have a slower rate. Okay? Surface area is a third factor. Surface area is a third factor that affects the rate of a reaction. Greater surface area is when you have a small particle size. Okay, so if you chew your food up into really small pieces, or if you chop something up, then it'll have a large surface area, a small particle size. If you have a greater surface area, you'll have a faster reaction because there will be more collisions. And again, this will be part of our demonstration tomorrow. Okay? As surface area increases, the rate of the reaction increases. I like to think of it, don't ever do this, but if you swallow a hamburger whole, okay, that has low surface area. So it'll take you forever to digest it because the enzymes and chemical acid in your stomach can only get the top and the bottom, right? And maybe a little bit of the sides. But if you chew your food and you break down that hamburger into really small pieces, okay, well now you can still get the top and you can still get the bottom, but you can get all this space in between as well. Those enzymes can act on all those space. There's more contact between your hamburger and the enzymes. So high surface area would be fast. Small particle size, fast reaction. So that's why you should chew your food, right? Number 1, you won't choke, and number 2, it'll digest faster because the enzymes can work on it faster. Okay. Catalysts may not be something that you've heard of before. Catalysts are enzymes in your body or other things that are specifically added to speed up reactions. So when you add a catalyst, you increase the rate of a chemical reaction. Okay? They do this by lowering the energy required to react. They lower the activation energy. And again, I'll show you how a catalyst affect the rate of a reaction tomorrow. But the presence of a catalyst makes reactions go faster. They catalyze. They make things go faster. They do not really participate in the reaction. They're unchanged. So they make it go faster, and then they return to their original state. Catalysts make reactions go faster. Nature of the reactants. What you're reacting plays a role in how quickly or slowly things react. Things that are covalently bonded are larger than ionic compounds. Okay? And therefore they're slower. Because in order for a covalent thing to react, you have to break more bonds. So covalent reactions tend to be slower than ionic reactions simply because of size. There's more breaking and making when a covalent substance is involved than when an ionic substance is involved. And finally, pressure. Pressure only affects reactions involving gases. It has very little effect on solids or liquids. Okay? And basically an increase in pressure increases the concentration. You squeeze the molecules together. And if you squeeze the molecules together, you increase the chance of collisions. So by knowing factors that affect reaction rates, you can either speed up or slow down reactions depending on what you want to do. Again, I will show you many of these tomorrow in class in a demonstration. That's it for tonight, everybody. Make sure that you have an answer to the 2 questions I had asked you to have an answer to. That's what I'll be checking, okay? The first one I wanted you to answer was, write the very first question in your notes. What is the difference between this collision and that collision? You should have a response to that. And you should also have a response to what's the difference between an effective collision and an ineffective collision. So that is where we'll start tomorrow. Enjoy your night, and we'll see you bright and early tomorrow morning. Bye-bye.